Hello, everyone. Thank you very much for coming to this talk. I know there's at least one other really good talk going on right now that my friend Sam Newman is giving, so thanks for coming to mine. It's my first time speaking at GOTO. I'm super happy to be here. I've heard about GOTO and Yao over the years, but I never made it out to Aarhus, so it's great to be here in Chicago to speak here. So just a very quick background about me. I used to work for ThoughtWorks back in the early mid-2000s. So I did a lot then with Agile and continuous integration and continuous delivery and all that good stuff. And then I moved to New York in 2006, so 11 years ago, working in finance companies and ad tech. And the reason I'm talking with you all today is that about a year ago, I started getting super interested in this area of serverless. And I got so interested, in fact, that I decided that I was going to write an article about it. And my good friend Martin Fowler offered to host it on his website, and that was very nice of him. And then it proceeded to get on Hacker News and was quite popular, which was a shock. And it was so popular, in fact, that at the beginning of this year, I decided to start my own consulting business, specifically in the area of serverless, with a good friend of mine, John Chapin. And this is what we do. Serverless is literally what we do. And really, what I have come to care about most in my career is people and trying to help people be the most effective they can be in engineering teams. And whether that's through management or through engineering with them, that is what I care about. And the reason that I like serverless so much, which may be surprising to some of you, is because of the potential it has for making people more effective. The resources for this talk are at this link. There's quite a lot of quotes and links in this talk. I steal at will from various friends of mine, but I quote most of them. So there's a Google Doc at this link, which you can find from my Twitter, which is there, together with a nicer font. So I had a nice font when I was going to present this on my own laptop. So we're looking at a bit plain font right now, but you'll see the slides in there. And if you can, hold the questions to the end. I'm going to be around for today and tomorrow, so I'm happy to answer questions afterwards. But let's get going. So where am I coming from before we get started? So as I said, I worked for ThoughtWorks in the early mid-2000s, and I was very into Agile and continuous integration, continuous delivery, and DevOps as it became. And I've also been friends with Dan North, and lucky to have him as a mentor, and have been talking about a lot of what he's been sort of chatting around for a while ago. Some of you may have been in Dan North's talk earlier, and it's sort of a bunch of stuff that he's been talking about. And really where we're getting to is that over the last 20 years, we've seen the lead time for delivering software decrease from years to weeks. And now we actually see an opportunity to reduce this further to days or even hours. And with this, we can transform our way of producing software to one of continuous experimentation. Well, what advantages does this bring? And what challenges would we face in getting here? And how would we surmount those challenges? Well, those are some of the questions that I want to explore in this talk with you today. So in this first section, I want to take you on a journey from how life used to be in software engineering to how it can be today. But first of all, let's all get a little philosophical together. What is the point of software engineering? It's a question we don't think about very often. One answer is to enable our customer or our users to be more awesome. And that means to make them able to do something that they couldn't even think about doing before. Or let them do something that they've already done before, but far more efficiently, or at far higher quality, or at less cost. I borrowed this question from latecomer to the room Dan North. Borrowed, stole. And he has a slightly different answer to this question. He says, the goal of software is to sustainably minimize lead time to business impact. And the point is that we're not here just to deliver software. We're not in the deliverables business, whatever you may have been told. We're interested in outcomes. That is, the delight of our users and what they can do with our software. Now, Dan also talks here about lead time. And in fact, a key part of improving our impact is reducing lead time. And lead time, in my opinion, is the time that we have an idea about how we can make our customers more awesome to actually giving them that capability. So reducing this lead time is our goal because it gets the useful software in the hands of users faster. That's more effective for them. And as a nice side effect, it often unlocks revenue for us earlier. But it also lets us try far more ideas. And why is that important? Well, I'll explore that in a little while. But first of all, a quick history lesson. Who here, quick show of hands, who here has been in the industry for more than 15 years? Yay, lots of you, yay. Hi. So those of you that put your hand up will know this, and those that you didn't might not know this, but 15 plus years ago, it normally took anywhere from 6 months to 2 years to deliver software. Well, why on earth did it take so long? Well, first of all, releasing software was really expensive. And this was because change management was expensive, and testing was expensive, and a whole other multitude of reasons. And so what we did was we optimized our process for large groups of people to work on one product area with a small number of releases. Infrastructure was also expensive, and so was the labor to manage it. And so we optimized our architecture to reduce the total number of components that we deployed. We often used multi-tenancy of various configurations and various customers into one runtime. Additionally, changing infrastructure was expensive. We needed to use the same infrastructure over months or years for it to be cost-effective. And this is a big reason why traditionally our production infrastructure is mutable, even though that brings a whole bunch of complexities. So all of these constraints drove us to a project mentality in how we worked in industrial software teams. We needed significant technical, data, and organizational coordination across large groups of people, leading to processes like waterfall and techniques like Gantt charts. Hello, old friend. Over the years, our constraints have changed. Releasing is not nearly as expensive as it used to be. We've got practices now like continuous delivery that allow us to optimize our build, test, and deployment processes through extensive automation. We've also seen huge reductions in the cost of infrastructure and the management of infrastructure through the maturing of public clouds. And not only have the overall costs of our infrastructure been reduced, but we can now also modify much of our infrastructure without loss of capital because of the elastic provisioning that the cloud gives us. Immutable infrastructure is now a reasonable possibility, an actual way that a lot of us work, which has allowed the new trend of thinking about our servers as cows rather than kittens. And because of these changes and constraints, we are now able to release software much more frequently. A continuous deployment of several releases per day is now commonplace in many companies. There's a quote here from Sri Kote of Comcast Cable, so quite a big company. He said this last year: "We used to ship our product every 12 to 18 months. In a 3 to 5 year period, we shipped 3 or 4 releases." 3 or 4 releases in 5 years. Now we ship 3 releases every week. What a turnaround. So tied around with this sort of reduction in cycle time that we see here, we also see that lead time has decreased. Now we often talk about lead time for new features or products in days or weeks rather than months or years. And these reductions in cycle and lead times have changed how we approach software delivery. Instead of focusing on projects and deliverables, we can now spend much more time considering the product that we're actually trying to build. Or, in other words, instead of focusing on how many things we can build, our output, we can instead optimize for the effectiveness of our software in the hands of the customer. In other words, the outcome that it has. Now, a lead time of days and weeks is a vast improvement over the months and years that we used to have. But we can do even better. Adrian Cockcroft, who was the main cloud architect at Netflix as they moved to the cloud and is now at AWS, said this a couple of months ago. He said, "We're starting to see applications be built in ridiculously short time periods. Now we're actually thinking about lead time in hours. As we reduce our lead time further and further, we can start focusing more on two very important points. First of all, we don't know up front what the best solution for our customer is. What we're making isn't something that we've made before. Building software products is a complex problem. When we start working on a feature or a product, we have an idea of what we're trying to implement, but the problem is most of our ideas suck." Thank you very much, Jeff Patton. And it's true. Most of our ideas suck. Now, most of the time when we're working on implementing our idea, they feel great. It's like, yep, this is absolutely the idea that we should be working on, but history says we're wrong. History says most of the time that feature's going to be useless, it's never going to work, or it's just going to be kind of, eh. And occasionally, we'll come up with one that's brilliant. And in fact, if we have an idea where we can deliver, if we have an environment where we can deliver an idea from scratch in hours, we can try out many, many more ideas. And not all of our ideas suck, just most of them. In other words, we can play a numbers game, and this way we are far more likely to come across a winner, the one that is going to make our customer awesome. So we've already decided that pretty much all companies now have to be tech companies, right? Because if they're not a tech company, then a tech company is going to come along and blow them out of the water. That's just the modern economy that we now live in. However, enterprises can now start moving beyond just being technology companies and embrace experimentation as their core system of work. Startups have been using this thinking for years, using ideas from Lean Startup. They can build minimum viable products, assess success, and keep pivoting to try new ideas until they find one which works. Enterprises can now start thinking this way because of the much shorter lead times we are starting to see in software development. We need to stop thinking of our software organizations as feature factories. This mindset of the never-ending backlog is a remnant of working in a project-based, output-oriented environment optimized for few releases. And this system is out of date. Instead, we can transform our organizations into product laboratories, embracing a model of continuous experimentation. And this will allow us to build products that truly make our customers awesome. Now, such a significant rethinking of how we approach software engineering doesn't come with challenges. How do we get to this point of continuous experimentation? Well, let's look at some of these challenges across technical and organizational spectrums. First of all, some technical challenges. We need to minimize the amount of incidental complexity that we need to solve. But we still need to have valid, safe production deployment at scale. And we want to maximize the amount of our engineering time we can have on the core of the actual customer problem that we're trying to solve. We want to reduce the infrastructure cost and commitment for deploying a new system. An experiment might only last a couple of days, and we don't want to be locked into an expensive system. And we want to reduce the technology overhead from having so many different experiments. We're going to have lots and lots of small systems in this world, and how do we have sufficient decoupling between them? Now let's look at some organizational and cultural challenges. We need to minimize the time it takes to go from our code being ready to it actually being deployed for the first time. And there are many technical and process and organizational concerns that sort of come out of this. We need to change the culture of our organizations to encourage continuous learning. We're not doing the same thing repetitively in a feature factory anymore. And product innovation needs to be spread around the teams and not just the responsibility of product managers, so that we can source a whole raft of ideas and that we can move those ideas through our experiment engine fast enough. Now, this is going to be a much less structured world, and so we need to rethink how we approach the idea of safety. We need to enable a psychologically safe environment for experiments to fail. We need to maintain budgetary safety in a significantly more dynamic environment. And we also need to carry on maintaining appropriate security and data access safety. Now, these aren't the only challenges, but they're enough to get us thinking about the type of changes that we're going to need as we approach this world of continuous experimentation. And I'm going to spend most of the rest of this time talking about how we solve these challenges. The good news is that we've already got most of the tools that we need. So unsurprisingly, given that this is a serverless track, serverless is a key technique in how we resolve many of the technical challenges that we have in this brave new world. So first of all, I want to give you a very, very quick serverless reminder or overview for those of you that may be new to serverless. This is going to be very, very quick. I'm not going to go into much detail here at all. So serverless consists of various types of technologies. So first of all, we have things like Amazon Lambda, which allows us to write really small bits of code as functions, upload those to a functions as a service provider, and let that provider figure out how to scale and run and deploy and monitor and log all that code for us. Serverless also consists of things like mobile team hyper-efficient databases like Google Firebase. And it also consists of various sort of software as a service type things like Auth0, which allow us to plug in somebody else's logic for user management into our system. But serverless actually consists of some more older school technologies as well. It consists of things like S3. So I think Amazon S3 is the original serverless technology. And also things like Amazon DynamoDB, we pretty much classify as serverless. But what are all these things that I've just been talking about serverless products? What are the attributes that we care about here about what a serverless product is? So first of all, serverless products require no management of server hosts or processes. Yes, there are servers somewhere, but we're not thinking about them when we're using these services. Serverless products self-auto-provision and auto-scale based upon load. And what that means is that we don't have to think about where we're going to put our instances of our databases. We don't have to worry about how many machines that we're going to need. A serverless product will auto-scale and auto-provision for us. And finally, for what I want to talk about here, serverless products have costs based on actual precise usage, not something that we actually pre-plan and say, hey, we need capacity for X. Nope. Serverless just charges us for what we use. Now, serverless products have a bunch of other attributes as well, such as defining performance attributes based on what we actually need rather than host size, and things like implicit high availability. But those are less important for the context of this talk. So given that, we can start moving on to our challenges. And the first one up is this technical one. How do we minimize incidental complexity? Well, serverless can help us here because it provides us pre-built logic that we can incorporate as a service. And I'm thinking here about that product Auth0 that I just talked about. Amazon also have a similar thing called Cognito. And they also have things like machine learning service. And the point being here, for many of the things that we might want to experiment with, we don't have to write the code for that anymore. Because lots and lots of people have not just written the code that we can download as a library, but are actually managing that code for us on our behalf as a service that we can incorporate into our overall application. Serverless also provides a very lightweight model for the custom code that we do need to write. It's very, very easy and quick to get up and running with Amazon Lambda and similar products. I can actually deploy an Amazon Lambda running on API Gateway from scratch in 20 seconds. That's pretty fast and very lightweight. Serverless also handles a significant proportion of our systems administration setup for general compute, like Lambda, but also for data storage and communication and networking infrastructure. We can use a bunch of these services, databases and message buses without having to do any significant systems administration work. And serverless also scales out horizontally without any significant effort. And this is important because our experiments are often not going to be valid unless we can test them at scale. So we need systems that are going to be scaling like that as soon as we deploy them for the first time. And that's what we get with serverless. So that's how we minimize a lot of sort of incidental complexity, the kind of stuff that we normally come across, and how we can just focus on the code that's specific to our experiment. Next up, we want to reduce infrastructure cost. Now, remember, we're looking not just to reduce the overall cost here, but the commitment that we have for deploying a brand new system. We don't want to be tied into costs for 3 months or 6 months if we're just deploying something for a couple of days. Well, with serverless, we get very, very little overhead costs. Costs are actually based on actual precise usage. And so if we've got 10 users going through the system, we're going to pay for 10 users. If we have 10,000 users going through the system, then we'll pay for 10,000 users, but not until that point. And the good thing is that costs scale up from 0 and back down to 0 automatically. We don't have to do any cost management here or system management. That's what serverless gives us for us. And finally, there's an interesting point here that we get with serverless. So in traditional systems, it makes sense from a cost optimization point of view to co-locate a whole bunch of different features into one system. That's what we typically do, right? We want to do a new feature. We'll take our existing product and we'll add some code to our product. That's just the way we've got used to thinking. But one of the main drivers for that, even though we don't think about it this way, is that's cost optimization. Because if we wanted to 5 years ago, if we wanted to deploy a new system and new hardware and new processes every time we wanted to write a feature, that would be so costly. With serverless, we don't have that constraint anymore. It goes away entirely. And that really sort of brings down the amount of complexity that we have to worry about because we can just deploy the code that we want to in a greenfield way every time we want to create a new system. And I actually don't think that this point is one that the serverless community has completely grasped yet because it's such a big change to how we built systems in the past. And the final technology point of view, the technology challenge I mentioned was minimizing tech debt. So we need a technical platform that actively encourages decoupling of components. And that's what we get with the event-driven, granular architecture that comes with serverless systems. And serverless today provides a great foundation here, but there's still a lot of work that we need to do to figure out patterns of good, highly decomposed architecture that still work well over time. Serverless is new, and I'm not going to tell you that I have the book of, best practice serverless patterns in my back pocket, and anyone that says they have for the next 2 years is wrong. We've got to understand how to build these systems first, but we'll get there. Now, I want to mention something at this point, and this is sort of for those of you in the room that may be a little bit more used to serverless. Much of the time when people talk about serverless, they talk about reductions in cost, both from the infrastructure and from the amount of effort that it costs to run a system. And the cost savings of serverless are really useful and significant, and I talk about them a lot in other talks. But they're not the exciting benefits to me. They're not the reason that I decided to start a consulting company and start talking to people about this stuff. And if you're only using serverless for cost savings, you're actually missing a big trick. Serverless also offers us the chance to bring about the change in delivery mindset of continuous experimentation that I'm trying to show in this talk, and to really help our teams and the individuals on our teams really make themselves more effective. Now, we talked about all the technical stuff, and I talked about serverless and how serverless is going to save the world, but it's not. A technical platform is not sufficient for these challenges. We need an organizational framework that complements serverless to help us solve the remaining challenges. So let's dig into those other challenges that I mentioned. So continuous experimentation is about both continuously delivering new tests, but also about making those tests provide ever more value to our users. So how do we need to change our organizations to make this happen? Well, the key lever as we start looking into organizational concerns is DevOps. But specifically here, I'm talking about DevOps culture. And that is bringing development, operations, and several other engineering activities much, much closer together, rather than having them performed in strictly siloed organizations. Now, in many cases, we're going to bring these activities onto one team. But if not, then we need to try and figure out how to get rid of really sort of static work queues between them. Now, the DevOps handbook, which came out last year, is going to be a huge help for you as you start to expand your thinking in this way. And it's really the most up-to-date digest of everything DevOps by the leaders in the subject. So it's written by Gene Kim and Jez Humble and a bunch of other people. It's really quite extraordinary. I used this book a ton when I was preparing this talk, and was like, the number of sticky notes I had sticking out of it by the end was amazing. I can't recommend this book enough for those of you that are thinking about DevOps as an organizational thing and not just about automated delivery. Okay, let's get back to our challenges. So the next challenge is, how do we minimize initial deployment time? So DevOps has done a great job of improving our cycle time, allowing our teams to practice continuous deployment. And continuous deployment is the idea where when we make a commit to trunk in version control, then there is a fully automated process that gets that out to production. And continuous deployment is amazing. I mean, I was talking about this with Chris Reeds, who's sitting there, and Dan, who's sitting there 10 years ago, about how can we make this happen? It would be extraordinary. And now it's sort of like, yeah, if you're a good company, this is what you do. It's like, wow. Now, continuous deployment techniques are really useful for us in what we're trying to do here with continuous experimentation. But we actually need more than that. We need to improve our zero to production time. And let's remember what we're up to here. What we're saying is that we want to build new systems within a few hours. And much of that time is going to involve coding, so that leaves very, very little time to actually launch our software. Maybe an hour or two, or maybe just minutes. So in order to have this ability, we need to be able to have automation to bring up new systems and have a platform in serverless that can react to our requests really, really easily and quickly. So we need all that technology there, but we also need the process and the culture within our organizations to support that. It's not enough to say, for an engineering team to have something ready to deploy and then hand it over to a DevOps team queue, he says in quotes, because that's not a thing. And then wait 3 days for it to get deployed for the first time, right? We've lost our entire feedback loop cycle there. So I'm not saying that operations folk have to be on the same team, but we have to be able to have this really, really fast process. And management and organizational culture needs to support that way of working. DevOps is far more about culture and people than it is about automated builds and automated deployment. And if you read the DevOps handbook, you'll know that. So there's no point having continuous experimentation unless we also have continuous learning. A big point of each experiment is feedback for figuring out what the next experiment is going to be. But oftentimes, this idea of continuous learning is not the way that we've worked traditionally in our organizations. When we're engineers in feature factories, we take requirements, we crunch them up, often with the same old techniques because we're under time pressure, and then we repeat. There's no learning there, it's just robotic. Now we need to place learning as important as delivery. And this will come in various forms. First of all, we need to tear up the backlog. We need to change our approach to management. No longer is it useful to build backlogs of work 3 months out and track progress to this as part of our effectiveness. That's the old way of thinking. We need to continuously learn and adjust to what our product needs to be. The change is also on us as engineers. When we're in the process of writing code, what are we optimizing for? Writing the perfectly designed, highly efficient solution isn't necessarily the most appropriate thing to do when we're trying to learn about technology or the customer's need. Perhaps copying and pasting code is actually the best thing sometimes, as long as we commit to stabilizing it at a later date if it proves valuable. Mostly what we want to do is the smallest amount of work in order to test a hypothesis. Now, Dan North over here has been doing a lot of great work on this front for a few years with his software faster work. If any of you here in Dan's talk this morning, some of you were, right? So you saw all those 20-odd, 30 or whatever it was patterns on the wall. Like a bunch of those things are around how do we think about engineering in highly effective teams. And Dan has been doing some great work here, and I've been completely, stealing ideas from him in this slide. And so I really encourage you to go and look at some of his stuff. And there's links to his stuff in the resource document for this talk. It's also the whole team's responsibility to change how we think of ownership. So product management is now a mindset and not an individual. The most effective engineering teams are the ones that consider customer affinity and not just the best technical solution. Not every individual needs to wear every single hat. We don't need everyone to be thinking about testing and ops and product management and engineering, but we do need to sort of soften or break down the silos of our roles across software delivery, including the non-technical ones. Now, I've seen many, many developers excel in this area, and when we treat all our engineers as just code robots, then we're really not untapping their full potential. So, as we change product development from being a project process of regular cadence over time to one of continuous experimentation and feedback-based redirection, we need to drastically change how we approach risk and safety. Experiments are going to fail, and product expectations will mutate, and the requirements of our technical environments are going to change and sometimes change drastically and quickly. Now, safe experimentation is not a contradiction in terms. Science labs do this stuff all the time. So how do we do this in our product labs? Well, first, and in my mind, most importantly, we need to allow our people to feel safe by creating an environment where failure is not something to be scared of. Now, Google figured this out years ago. The New York Times wrote a great article about Google's own introspective studies, and it includes this quote. Google's data indicated that psychological safety, more than anything else, was critical to making a team work. And this might seem reasonable. And it's like, yeah, okay, that seems good. But how much effort do we put into this in our own organizations? How often do we actually put safety as a thing that's like, oh, we're going to think about that? The best companies adopt failure as part of their process. Now, here's a quote from Jeff Bezos, CEO of Amazon, on the Fire Phone. Who here remembers the Fire Phone? Who here remembers what a debacle it was? Right. So Jeff said this. He said, if you think that's a big failure, we're working on much bigger failures right now. And I'm not kidding. Some of them are going to make the Fire Phone look like a tiny little blip. Maybe he was talking about S3 outage in US East the other week. I don't know. The point is here, if we value experimentation, we must actively embrace failure as learning and not just merely treat it as an unfortunate side effect. So how do we go about making our cultures ones in which it is safe to fail? Well, one area to start with thinking about is blameless postmortems. So here's a quote from Bethany Macri, an engineer from Etsy in New York, about blameless postmortems. She said, by removing blame, you remove fear. By removing fear, you enable honesty, and honesty enables prevention. Now, this quote is directly from the DevOps handbook, again, and there's a huge amount in the book specifically around psychological safety. Of course, it's not just enough to think about the safety of our individual coworkers. We also need to think about the safety of our business. Otherwise, we'll all be out of jobs. So there's several areas to be concerned about here, but I want to talk about infrastructure budget. And how do we make it safe to create whole new stacks of infrastructure on a frequent basis without bankrupting our organizations? Well, first of all, we need team visibility and ownership. The best people to understand how to have the most efficient hardware or systems is the teams that are using them. So give them access to knowing what their costs are. And more importantly, give them ownership and the ability to drive their costs. We can also introduce a whole bunch of new automation and tooling around this. So if teams can know how much they've spent on a daily basis and know how that has changed in the last day or week or month, that's going to allow them a lot more control over what they're doing. And we also need to actively seek out, we actually actively need to seek out bits of software and systems that are not owned, and so that we can either assign ownership to them and so that they can be managed properly, or so that we can just delete them. I also think that we need to introduce per team and per account soft and hard cost limits. Now, this is a new thing, and I think that our vendors need to extend their platforms to support this kind of area. Okay, our final challenge is data and security safety. So what do we need to do here? Well, we need to make security work as much part of a team's responsibility as anything else. I'm sure Aaron would agree with me. And consider it like operations, like we now consider operations a thing that we do on highly effective dev teams. We need to think about security as part of what we do on highly effective dev teams. We need to build shared tooling across an organization in a way that protects data, but also gives enough flexibility for experimentation. Where possible, we want to give teams autonomy for many access controls. And then we want to build ways of having review into that so that other people know what changes have been made. But there are going to be some changes that are actually going to need change request processes. And where we need that, then we need to actively update those processes to optimize for flow so that we don't slow down our experimentation process, even when team autonomy alone is insufficient. Hey, so that's all of our challenges discussed. Yay. Well, there are many areas to consider when we think about moving to continuous experimentation. But as I hope you've seen, we actually already have a lot of the tools that we need to solve them. But what about the questions that we haven't answered and the challenges that we haven't yet discovered? What is our framework for considering these? Well, this is where I think modern Agile can help. Modern Agile is a set of 4 values that take the core of how Agile software development was originally conceived and brings it up to date for an experimentation-focused culture. It comes from Joshua Karievsky and the rest of the folk at Industrial Logic, which is a company out in California, who have been using extreme programming and Agile techniques for as long as I have. Now, as a set of values, modern Agile doesn't give us a prescribed process for solving all of our problems. But it does give us a framework for asking really useful questions. Now, I use these values as I was driving out the challenges that I wanted to discuss in this talk. So let's look at these 4 values now and see where they fit as we consider transforming our feature factories to product labs. The first value is make people awesome. We're considering customer satisfaction here, but we're also considering our own organization's people, in the understanding that the more powerful our teams become, the more that we can do for our customer. So this brings up some questions. It brings up questions like, what will make our customers more awesome? And how do we give our team members superpowers? Next value, experiment and learn rapidly. This is taking the ideas of lean startup and bringing them to the larger world. Questions here are, what can we learn on a regular basis? How do we approach experimentation in a structured form? Sorry about the fonts here, by the way. This is what I was talking about earlier when I'm not using my laptop, I'm using Chris's. So that's why weird text. Sorry about that. Next value, deliver value continuously. Unsurprisingly, the root of this value is all the work that has been done over the last few years on continuous delivery. But the point about continuous delivery isn't just about a process of turning wheels. How do we make what we do valuable? And how do we get that value frequently and regularly to our customers? And the final value, make safety a prerequisite. So it's placing safety as high a thing to be concerned about as anything else within our new world. So with such an environment of change and uncertainty, how can we make it safe to experiment? We need a safe environment for our team members, our companies, and our customers. What are the areas of risk in our daily work? What are the limits of experimentation of our experimentation environment? And how do we build appropriate safety nets? So in this talk, I've shown that we now have the ability to have idea to production lead times of hours and not years. And this enables us to think about how we approach product development in a new way, one of continuous experimentation rather than the old project mindsets that we've used before. Continuous experimentation is really a natural progression from continuous deployment through continuous delivery, through continuous deployment, continuous integration, sorry, through continuous delivery, continuous deployment, and now we have continuous experimentation as an option. Serverless provides us with a technical platform to do this, but it alone is not sufficient to enable this change. Additionally, Modern Agile provides a value framework, DevOps provides the principles and practices, and Dan's software faster work with patterns of effective teams gives us new ways of considering how we work as engineering teams and how we think about engineering itself. So this leaves my question to all of you. How will you transform your organization from a feature factory to a product laboratory? I hope I've given you some inspiration and some ideas that you can take back to your own teams. So as I mentioned before, there's some resources for this talk at this link, which you can find very easily on my Twitter, @MikeBRoberts. I also, as I mentioned, have a company. We're dedicated to serverless and all of these kind of questions. So feel free to email me. I'll be around today and tomorrow, so feel free to grab me. I have cool Modern Agile stickers for those of you that like stickers on your laptops. And most of all, thank you so much for coming. We got time?
Yeah, we have about 5 minutes if you want to take some questions.
Yeah. Let's take
them up on stage.
Let's take a couple of questions. And one at the back. Yeah, so the question is, if you already have a really robust continuous delivery pipeline, it sounds like you have a really robust continuous delivery pipeline, what is the point of moving to, which is using sort of traditional technologies like EC2? And by the way, I have no problem with EC2 and containers. We're all in one big happy engineering family. What is the point of considering serverless and the ideas that I've been talking about today when you already have a really robust continuous delivery pipeline? Great question. The thing I would say, and I kind of want to emphasize, and one of the things I'm trying to emphasize here is that continuous delivery, even as we got used to it over the last few years, it gives us this great cycle time for an existing product or an existing project or a code base. But normally it takes a whole chunk of time to get that set up. What I'm saying is, if we want to actually build something brand new, if we want to build a new mini system, it can take a really long time to set up all of that infrastructure from scratch. So we're actually sort of forced into building features into existing systems, whereas sometimes for it to experiment, it might be better just to have a clean slate and try building a new system. And so what serverless does and some of these other technologies do is they give us a much quicker way of going from a clean slate from nothing to having a fully deployed system. Okay, well, I think we've got time for one more question over the right. Yep. So this is really, so the question is, so what if I have a whole bunch of how I've built my system sort of locked up within a particular vendor cloud provider system? Isn't that going to be a pain to move it to a different cloud provider? And what if I want to have mixed multi-cloud, as it's called? it's a really big question, and it's not just about serverless. This is a question that we are hitting now as an industry. As we start embracing public clouds more and more and more, what are we doing there about lock-in? Now, the interesting thing about this stuff, and it's a question that I've been thinking about a lot because it is such an important one when we start thinking about this stuff, is that it's not binary. The sum of what we do in the serverless world is really, really easy to migrate. So for instance, actually, Lambda functions, I think Chris just left from AWS. Lambda functions are actually really easy to migrate because the code in a Lambda function, you don't actually have to have any vendor-specific libraries in there at all. Excuse me, so the code itself is really easy to migrate. Where the tricky part comes is how that code is integrated with all your other things. So if you have Lambda listening to Kinesis and then writing to Dynamo and blah, blah, blah. And we have this interesting situation with the cloud right now, which is that a bunch of cloud technologies are very much commodity. So things like file storage is pretty much the same, whether you go from Amazon to Google or whatever. But some of these other sort of higher level features are not commodity, and there's actually differences across them. And so there's a real question here when you're dealing with this stuff. It's like, do you sort of code to the lowest common denominator so that you can migrate around, or do you embrace all of the extra features knowing that you're going to be locked in? And this is a big thorny question, and it really depends on where you are as an organization and what you're trying to do and what your priorities are. But it's more than accepting that lock-in is a factor there and deciding what to do about it and knowing that it's a more sort of holistic problem across your organization is one that's worth thinking about. Okay, we are out of time. I'll be outside. I thoroughly recommend sticking around for Peter's talk, who's going to be chatting next. Thank you again for coming.